Greetings of the day. Hello everyone. I am Asif Moiz, Assistant Professor in the Department of Electronics and Communication Engineering in Madanpalle Institute of Technology and Science, Madanpalle. Welcome to the course of Communication System. Today we will discuss about the communication system or engineering communication system. An introduction to communication system is also, we can say, overview for the communication system is elements of communication system, then classification of communication system, line and radio communication, transmission channel. Then we will read modulation, demodulation, classification of modulation, and then continuous wave modulation, in which we will read AM, FM, PM, pulse modulation, PAM, PWM, PPM. We will read then transmission system and transmitter system and receiver system. We will read. Okay, a system is an arrangement of physical components connected in such a manner as to form or act as an entire unit. In its basic form, uh, the system would respond for an excitation. Excitation is the input and response is an output. Uh, Communication is a process of conveying message at a distance. In other words, it can be defined as the process of transfer of message from one place to another, from source to destination. If the destination distance involved is beyond the direct communication, the communication engineering comes into the picture. So transmitter and a channel or transmission channel is there, and then receiver is there. Communication system, uh, here is the information source, then it is we have a transmitter, then transmission channel with a noise source also comes there, then receiver and destination. So another block diagram is there. Input message enters into the input transducer, then it goes to the transmitter, then to the transmission channel or transmission medium. From there it goes to the receiver, or then after output transducer, and then output message comes. So input transducer is used, basically it converts sound energy into electrical energy. Then transmitter system is there, and from there the signals are transmitted to the transmission channel. Transmission channel can be the wires or lines of wires, and it can be ionosphere also, free space also. So from the transmission channel it goes to the receiver, and then output transducer converts electrical energy to sound energy, and then output message goes to the destination. Okay, the branch of engineering which deals with the communication system is known as telecommunication engineering. So telecommunication engineering is classified into based on the two transmission media. They are line communication. Line communication means transmission line communication, and a radio communication or radio wave communication. So channel here has the two types. The one is based on the transmission line, and another is radio wave or free space or ionosphere. Okay, and line and radio communication. So in line communication, media of transmission is a pair of conductors called transmission line. The technique signals are directly transmitted through the transmission lines. The installation and maintenance of the transmission line is not only costly and complex, but also overcrowds the open space. But radio communication does not depend on transmission line. Here, media of transmission is free space. So the two main categories of transmission channel is one is the line or transmission line or conducted media. It is a physical media. The channel is made up of metallic cables such as coaxial cable, twisted pair, parallel wires, and others, or fiber optics cable, whatever. But it is a physical. But another is a radiated media or free space media. This is the medium where transmission of signal is carried out by the propagation of electromagnetic wave. The main applications are in radio broadcastings, microwaves, and satellite transmission systems. Modulation. So modulation is defined as the process by which some characteristics, that is amplitude, frequency, and phase of any carrier signal, are varied in accordance with the modulating wave or message signal or information. So one modulator is there, and in that modulator input is our message signal and output is modulated wave or modulated voltage or modulated signal. uh, Modulation is a process in which baseband signal or message signal or information signal or low frequency signal goes from one side, and from other side RF wave or high frequency wave, radio frequency wave or high frequency wave, termed as carrier signal, it goes from other side as an input. So two inputs are baseband signal and carrier signal, and output is modulated wave. After modulation, the modulated wave is the output. uh, this is transmitted by a transmitting antenna, then it goes to the receiver side after transmission channel. After the flow of signal from the transmission channel, it goes to the receiver side where demodulator is there, so demodulation occurs there. So output signal or channel out the signal from channel output goes to the demodulation, and from there the original message is extracted or taken out. So demodulation is the in reverse process of modulation, which is used to get back the original message signal. Modulation is performed at the transmitting end, whereas demodulation is performed at receiving end. In analog modulation, sinusoidal signal is used as a carrier, whereas in digital modulation, pulse train is used as a carrier. So types of modulation, if we see, there are two types: continuous wave modulation and other is pulse modulation. So continuous wave modulation, when the carrier wave is continuous in nature, the modulation process is known as continuous wave modulation. When the carrier wave is a pulse train in nature, the modulation process is known as pulse modulation. So on the basis of these two types, we can have this table in which continuous modulation has two types: continuous wave modulation and pulse modulation. So continuous wave modulation has again two types: amplitude modulation and angle modulation. The amplitude modulation has another three types: double sideband suppressed carrier, so DSB-SC, then SSB single sideband, and vestigial sideband, that is called VSB. Angle modulation has again two types: frequency modulation and phase modulation. The frequency modulation has again two types: wide band FM and narrow band FM. So uh, these are the types. And if you come across the pulse modulation, this is pulse analog modulation and pulse digital modulation. These two types are there in pulse modulation also. The pulse analog modulation has again two types: pulse amplitude modulation, also called as PAM, and pulse time modulation. So pulse time modulation again has uh, another type. One is pulse width modulation, also called pulse duration modulation or pulse length modulation. So pulse width modulation means PWM, pulse duration modulation means PDM, and pulse length modulation means PLM. And one is PPM, that is pulse position modulation. And another type of pulse modulation is pulse digital modulation, in which PCM, DPCM, and DM is there. So PCM is pulse code modulation, digital pulse code modulation or delta pulse code modulation, and DM is delta modulation. So if we see one by one, the continuous wave modulation, the amplitude modulation is the first one. What is amplitude modulation? A modulation process in which the amplitude of the carrier is varied in accordance with the instantaneous value of modulating signal or message signal, keeping other two variables as constant, that is keeping the frequency and phase as constant. Frequency modulation is a process in which frequency of the carrier wave is varied in accordance with the instantaneous value of modulating signal, keeping amplitude and phase as constant. In phase modulation, phase of the carrier is varied in accordance with the instantaneous value of message signal or modulating signal, keeping frequency and amplitude constant. So one parameter of the carrier signal is varied in accordance with the message signal, but keeping the other two variables as a constant. So this was continuous wave modulation. Here we can see the waveforms of amplitude modulation and frequency modulation. First waveform is the sinusoidal carrier, which is continuous in nature, so it comes under the continuous wave modulation. And baseband signal means nothing but the message signal only, or modulating signal or modulating voltage. Another third waveform is the amplitude modulation. Here we can see the amplitude is varying as per the instantaneous value of message signal or baseband signal. So somewhere it is amplitude is maximum, somewhere it is the amplitude is minimum. It depends on the values of the baseband signal at that position, at that point, or at that time. Okay, and then another last waveform is the frequency modulation, in which we can see the variation in the frequency, but amplitude and phase is constant at these points. Advantage and disadvantage of AM over FM. We can see advantage as a generation and detection of AM signals are very easy as compared to FM. It is very cheap to build, and due to the reason it is most commonly used in AM radio broadcasting. Disadvantage of amplitude modulation. Amplitude modulation has more loss of power as compared to FM. Amplitude modulation consumes more bandwidth also as compared to FM. It is more noisy than FM. FM is less noisy than AM. Amplitude of AM and FM, we can see AM is used in radio broadcasting. FM also is used as a radio broadcasting. There are three types of amplitude modulations: double sideband with suppressed carrier, so that is called DSB-SC modulation. One is single sideband modulation. A third one is vestigial sideband modulation. It depends on the bandwidth consumed by them. So these are the methods. Okay. Now we come to the pulse modulation. As we have seen the continuous wave modulation, three types: AM, FM, PM. Here also in the pulse modulation we have three popular modulation types. One is pulse amplitude modulation, second one is pulse width modulation, and third is pulse position modulation. In pulse amplitude modulation, we can see PAM is an analog scheme in which the amplitude of the pulse is proportional to the amplitude of the signal at the instant of sampling. Or in other words, in PAM, pulse amplitude modulation, amplitude of the pulses is varied in accordance with the instantaneous value of modulating signal. Another analog pulse forming technique is known as pulse duration modulation, PDM. This is also known as pulse width modulation. Pulse position modulation is closely related to PDM, pulse duration modulation. Here we can see the amplitude of the pulses, carrier pulse train, is varying according to the baseband signal, according to the original information. So amplitude is varying, but position and width is constant. In pulse width modulation, we see amplitude is maintained constant, but the width of each pulse is varied in accordance with the instantaneous value of analog signal. Here we can see in the waveform also the width of the carrier pulses are varying. They are not the same. Width is not same, but amplitude and position is same, but the width is varying. So in PWM, information is contained in the width variation only. In pulse width modulation, the width of each pulse is made directly proportional to the amplitude of information signal. Pulse position modulation. In this type, the sampled waveform has fixed amplitude, width, whereas the position of each pulse is varied as per instantaneous value of analog signal. So in pulse position modulation, position is varying, but amplitude and width is same. So in PPM signal, PPM signal is further a modification of PWM signal only. PPM signal can be generated from PWM signal. All the PPM pulses have the same amplitude and width. The information is conveyed via changing position of the pulses. The gaps between the pulses of a PPM signal contain the information regarding the modulating signal. So waveform of PWM and PPM, we can see the first one is the baseband signal, and then pulses are there, and then in pulse width modulation we can see width is changing but amplitude and position is same, and in PPM we can see position is changing, amplitude and width is same of each pulse train, but position is changing. So in pulse width modulation, we see the width is changing, and in pulse position modulation, position changes. Okay, radio transmitter. As we can see, it is a device to transmit the radio waves. So AM transmitter takes the audio signal as an input and delivers the amplitude modulated wave to the antenna as an output to be transmitted. The block diagram of AM transmitter is shown in the following figure. Audio signal is there, pre-amplifier, then AM modulator is the very important components, which has two inputs. One is coming from audio signal and one is RF oscillator from which carrier signal is coming. So in the AM modulator, from one side message signal is coming, from other side carrier signal is coming, and they are then modulated. So modulated wave is coming as an output and it goes to power amplifier, and then from the power amplifier it goes to the transmitting antenna, from where they can be transmitted into the ionosphere or transmission channel. So AM transmitter, another block diagram, we can see the microphone is there, and then from microphone sound energy is coming. Then signal transducer is there, which converts sound energy into electrical form, and then it goes to the modulating amplifier. From where it is modulated, it goes to the modulator. In the modulator always has two inputs and one output. So another input terminal is connected with the carrier wave generator and RF amplifier, from where carrier signal is coming. So from one side message signal, original message is coming in the electrical form, and from other side carrier signal in coming in electrical form. They are then modulated, and the output of modulator is nothing but a modulated wave which goes to the power amplifier, and from there they can be transmitted through a transmitting antenna into the transmission channel. Either it can be a transmission line or coaxial cable or wires, or it can be ionosphere, free space also. So working of a transmitter can be explained as follows. The audio signal from the output of the microphone is sent to the preamplifier, which boosts the level of the modulating signal. The RF oscillator generates the carrier signal, and both the modulating and carrier signal is sent to AM modulator. From there they can be transmitted to power amplifier, and a power amplifier is used to increase the power levels of amplitude modulated wave, that is called AM wave. This wave is finally passed to the antenna to be transmitted in the transmission channel. So function of AM transmitter, if we talk about what is the function of a radio transmitter, so AM, then we can say AM transmitter is an electronic device used in telecommunications to produce radio waves in order to transmit or send data with the help of an antenna. A transmitter is able to generate a radio frequency alternating current that is then applied to the antenna, which is in turn radiates as the radio waves. Components of a transmitter, we can see what are the components of a transmitter. Basic components are message signal generator, then transducer, then carrier signal generator, from where RF wave or high frequency wave carrier signal is coming, then modulator. I have told has two inputs and one output. In one input we give message signals, and from other input we give carrier signals. They are then modulated, and then modulated wave is the output of a modulator, which goes to the transmitting antenna to be transmitted in the transmission channel, whether it is a transmission line or free space. Then if we talk about a receiver, then RF amplifier is used after the receiving antenna. RF amplifier and tuning devices are there. Then they goes into a mixer. In the mixer, one more local oscillator is connected, from where carrier signal comes, and then after mixer the output of a mixer goes to the IF amplifier, which is intermediate frequency amplifier, and after filter stages are also there. After that the received signal goes to the demodulator, from in which the inverse process of modulation goes on, and after demodulating the signals, carrier signal is separated from the original message signal. Then this message signal goes to the audio amplifier. After audio amplifier it goes to the output transducers also, from in which electrical form of that original message is converted to sound energy, and then after sound energy it goes to the loudspeaker, from where we can see we can hear the original message. So the in the receiver section we get the signals, either it is in electromagnetic wave form or it is in the electrical form. It is demodulated in the super heterodyne receiver, and then it is converted to original message form, and then it goes into the uh, destination. So this all is the process to transfer the information from source to destination, or from initial point to destination point. Okay, then summary, we have seen the elements of communication system, then classification of communication system, then modulation and demodulation process we have seen, different types of modulation, especially amplitude modulation, frequency modulation, and phase modulation we have seen, and pulse amplitude modulation, pulse width modulation, pulse position modulation we have seen, then transmitter and receiver systems we discussed. So this was all about this communication system, or the basic knowledge of communication system. Thank you.